Now, this is our fourth method of solving differential equation. Now, this is not just any kind of differential equation. This is a linear differential equation. Now, we can only solve a linear differential equation by applying integrating factor method of solving linear differential equation. So now, to solve a particular equation, a particular differential equation, or a particular linear differential equation that follows this particular form, dy dx plus py equals q, where p and q are constants or function of x, then what we have to do is multiplying both factor by the integrating factor of x. Now, what am I trying to say? To solve a linear differential equation, it is all about multiplying that function by an integrating factor. Multiplying that function by an integrating factor, which will be an exponential function of x. So that integrating factor can be written as exponential integral p dx. So solving a linear differential equation which follows that particular form, what we have to do is express the first step we have to do is to express the given equation as this form. That's step one. Then our second step is to multiply both sides by the integrating factor, which is this. Is that okay? Then our third step is to solve. Now, it's basically two simple steps. Now, given this, let's take this particular example. Let's take this particular example. Our first example, which says dy dx plus 3y equals sine x. Now, I want you to look at this particular equation and look at this particular form of equation and see if they are a match. So now, looking at this is dy dx plus. Let's compare both equations together. This is dy dx plus py equals q. Now, can you see that comparing these two equations, I can say my p is equal to 3 and my q is equal to sine x. So you see, this is a linear equation. I can solve this by applying integrating factor. So you see that you can only solve the equation of this form by multiplying by integrating factor. So now let's solve this equation. This is dy dx plus 3y equals, so we don't need to express this in form of this particular equation because it has already been expressed as this form of equation here, because it has already been expressed as this form of equation. You get? So now, solving this particular equation, solving this particular linear equation, what is my second step? My second step is to multiply both sides by the integrating factor. Remember, we're multiplying both sides by exponential integral p dx. Right? So now, what's my p? Comparing these two equations, I can say, comparing these two particular equations, so what's my p? My p is what? Equal to 3. So my integrating factor will be exponential integral 3 dx. Right? So now, integrating this integral 3 dx, what will I have? So this is 3 integral dx, which gives me what? 3x. So my integrating factor is exponential 3x. Is that understood? Basically, when you identify your p in your integrating factor, you integrate the factor, then you have your value. Then I can say my integrating factor is exponential 3x. So what do? I multiply both sides by exponential 3x. So this is exponential 3x times dy dx plus exponential 3x times 3y equals exponential 3x times sine x. I follow. Divide both sides by exponential 3x. So now this is, so when now remember, when we are dividing both sides by exponential 3x, we can say that this expression here, this expression, we can also be written as y as the derivative of y times exponential 3x. Now how do we get this? Now it's just a very simple term, because you just take the dependent variable and the integrating factor together. So integrating the independent variable and the integrating factor together will give me this expression. We can test it out. So instead of me writing this, I can write this. So which I will have now. If let me choose to integrate this, let me choose to differentiate it. So you see that differentiating this factor will give me this factor. So now let's differentiate it. Taking y constant, applying my product rule. Taking y constant and differentiating this one, I have y times exponential 3x times 3, right? Plus, taking this constant and differentiating this, I have exponential 3x times dy dx. So you see that this is actually giving me this. So instead of me writing this, I can replace it with this. Then I have the derivative of y times exponential 3x is equal to exponential 3x times sine x, right? So now what do we do here is to integrate. So integrating both sides, we have y times exponential 3x is equal to integral exponential 3x times sine x dx, right? So now this is what I have. So what do we do here? We have to integrate this, because we're actually looking for a more simpler equation with our constants, right? So we're actually looking for a more simpler equation, so we have to integrate this. So now integrating two functions of x, we apply what we call integral by parts, which says that integral of u dv is equal to uv minus v du, right? So this is the formula for integration by parts, where u and v are both functions of what? X. So now integrating exponential 3x times sine x, I can say let my u be exponential 3x and let v be sine x, right? And let dv, sorry, be sine x. Remember, this is u dv. Taking this to be u and taking this to be v dv, right? So now my u, into differentiating my u, that's du dx is equal to 3 exponential 3x, right? And integrating my dv, which is v equals cos x minus cos x, right? Integrating sine x, we have minus cos x. So making my du subject to formula here, this is 3 exponential 3x dx, right? Then you have v equals minus cos x. Then we put these values into the formula for integration by parts. So where my integral u dv, which is my exponential 3x times sine x, is equal to my u, which is exponential 3x, times my v, which is minus cos x, right? Minus my v, which is what? Minus cos x, times my du, which is what? 3 times exponential 3x dx, right? So this gives me exponential 3x, right? It gives me exponential 3x minus exponential 3x cos x, right? Plus minus is plus integral cos x times 3x exponential 3x dx, right? So now I want to integrate these two factors. Now before I do, if you look at this, there's an integration sign and there are still two functions of x. So taking my constant back to the integral sign, this is minus exponential 3x cos x plus 3 integral exponential 3x cos x dx. So I'm also having two functions of x here also, so I have to integrate using integral by parts. So using integral by part, integral u dv is equal to uv minus v du, right? Taking my u to be exponential 3x, taking my dv differentiating my u, I have the u equals 3 exponential 3x dx, right? Integrating this, I have v is equal to sine x. So putting these values into these values, my u is equal to exponential 3x times my v, which is what? Sine x, right? Equal integral, minus my v, which is what? Sine x, times my du, which is 3 times exponential 3x dx, right? So this is giving me exponential 3x sine x minus, taking the constant back to integral sign, this is 3 integral exponential 3x sine x dx. Now if you look at, we have actually gotten the same functions we started integrating for. From the beginning, we started integration by part. If you look at, we're actually having the same function, which is exponential 3x sine x here. So what can we do now? Because we are going to be having a repeated value of exponential 3x sine x. Let's say let I be equal to exponential 3x integral of exponential 3x sine x dx, right? So now let I be equal to exponential 3x sine x dx. So now anywhere I see integral exponential 3x sine x, I'm going to put I. So this will give me, taking this value, now replacing this value. Remember, this is what we just integrated, right? We just integrated this figure, right? So replacing this value with this value, we have minus exponential 3x cos x plus, replacing this with this, we have 3 open bracket exponential 3x sine x minus 3 integral exponential 3x sine x dx, right? So now opening the value of this, we have minus exponential 3x cos x plus 3 exponential 3x sine x minus 9, right? 3 times 3, which is 9, integral exponential 3x sine x dx. So anywhere I see I put exponential 3x. So anywhere I see integral of exponential 3x sine x, I put I. So this is minus exponential 3x cos x plus 3 exponential 3x sine x minus 9i. Remember, we are integrating u dv, and we said u is exponential 3x and dv is sine x, right? Which makes it u dv is exponential 3x sine x. So we are saying exponential integral of exponential 3x sine x dx will give me this, right? And anywhere I see I put, anywhere I see integration of exponential 3x sine x, I put I. So replacing these two with I have I is equal to minus exponential 3x cos x plus 3 exponential 3x sine x minus 9i. Taking this over to this gives me 10i. So this gives me 10i is equal to minus exponential 3x cos x plus exponential 3x sine x, right? Plus 3 exponential 3x sine x. So dividing both sides by 10, dividing both sides by 10, and dividing both sides by 10, we have I is equal to minus exponential 3x cos x over 10 plus 3 exponential 3x sine x over 10. So we have successfully integrated the right hand side. Remember, we are solving for an equation, right? With respect to an equation of my dependent and my independent variable. So all we have been doing is to integrate the right hand side. So since we have successfully integrated this right hand side, we bring it to the equation. Remember, don't forget your constant c, right? So bringing it to the equation, this is y exponential 3x equals minus exponential 3x cos x over 10 plus 3 exponential 3x sine x over 10 plus c. Dividing both sides by exponential 3x, this is y is equal to minus cos x over 10 plus 3 sine x over 10 plus c exponential minus 3x. So this is my equation. So is that understood? Now going on to our next example, which we were given to be going on for our next example, which we were given to be this, right? So now this is another form or another equation in which we are going to be solving by integrating factor. So the first thing we do, like I said, is to express it in the form dy dx plus py equals to q, right? Is to express it in this particular form. So how do we express this in this particular form? The first thing we do is to eliminate this x, right? So dividing both sides by x, dividing all sides by x, it will give me dy dx, right, plus y over x equals x squared, right? So now this is what I've successfully done. So now if you look at this particular equation, they are actually alike, because this is this and q is x squared, where p, if I separate 1 over x from y, I have my p to be 1 over x. So where p is equal to 1 over x, comma, and my q is equal to x squared. So now this is how we solve it. So now are we going to solve it? The second step you do is to find your integrating factor. So if your equation successfully aligns with this form, finding your integrating factor becomes the second step. So how do we find my integrating factor? Now we know that my integrating factor is exponential 3 exponential integral p dx, right? So my p is what? 1 over x, right? So this is exponential 1 integral 1 over x dx, right? So integrating 1 over x dx, let me solve it. Integrating 1 over x dx, we know that this is a linear function. So integration of the inverse of any linear function gives the natural logarithm of that function, right? So this is exponential ln x, right? So this becomes my integrating factor. So now what is your third step? Your third step is to multiply your integrating factor all through the equation. So how do we do? Multiply my integrating factor. I have exponential ln x times dy dx plus exponential ln x times y over x equals exponential ln x times x squared. So I've multiplied all through by my integrating factor. Then the fourth step is to rewrite this particular equation in a more simpler term. So I can say this equation can be written as taking my dependent variable, which is y, times and taking my integrating factor, which is ln x, ln x. So I can say the derivative of y times my integrating factor will give me this equation. The derivative of these two will give me this. So we can test it out like we did in the previous example. So then I can rewrite this. Instead of writing this, I write this equal to exponential ln x times x squared, right? Then what do we do is integrate both sides, integrating both sides. So integrating this, we have y exponential ln x equals integrating exponential ln x sin x integral exponential ln x times x squared dx, right? Now there's a rule that says exponential of ln f is equal to f. That is to say, exponential of any function of x which is represented as f will be equal to that function. If I say exponential of ln x squared will be equal to x squared, exponential of ln 3x will be equal to 3x, right? So exponential of any function will be equal to that function. So exponential of ln x will be equal to what? X. So I can say let exponential of ln x be equal to what? X, right? Then rewriting this particular equation, we have y times letting exponential of ln x to be x. Writing this equation, we have y times x be equal to exponential x times what? x square dx, right? Then x times x square give me what? X raised to the power 3 dx. Xy equals integral x raised to the power 3 dx. So having xy equals integral x raised to the power 3 dx, solving this, integrating x raised to the power 3 dx give me x raised to the power 4 over 4 plus what? C, right? And equals xy. So this is our equation. You can actually leave it like this, or you can say dividing both sides by x, dividing both sides by x gives me y equals x raised to the power 3 over 4 plus 6c over x. Or you can safely say x raised to the power 3 over 4 plus c x raised to the power minus 1. This is my general solution. Is that understood? So now let's go to our fourth method of solving differential equation, which is by BRNOULLI'S.